This is Euclid Book 8, proposition number 13. And you can see the illustration right here, and you can see it's very, very big. Alright. If there be as many numbers as we please in continued proportion, we've talked about this many times, and each by multiplying itself makes some number, the products will be proportional. And if the original numbers be multiplied by the products make certain numbers, the latter will also be proportional. What does this actually mean? Let there be as many numbers as we please, A, B, and C in continued proportion. Well, here's A, here's B, and here's C. So as A is to B, so will B be to C. Okay. Let A, B, and C, by multiplying themselves, make D, E, and F. Okay. So A times A makes D. B times B makes E. And C times C makes F. Okay. And if you multiply A times D, well, here's A, multiply it by D, then you're going to get G. Okay? A times D equals G. Alright? And B, right here, times E makes H. Okay. And C times F, okay, C times F over here is going to make K. Now we got that down. I say that D, E, and F and G, H, and K are a continued proportion. So what we're saying here, as D is to E, so will E be to F. And as G is to H, so will H be to K. That's what we're going to say. Alright. For let A by multiplying B make L. A times B makes L. A times B makes L. Alright. And let the numbers A and B by multiplying L make M and M respectively. Okay, so stop right there. A times L makes M. A times L makes M. And B times L makes N. B times L makes N. And again, let B by multiplying C makes O. B times C makes O. And let the numbers B and C by multiplying O make P and Q. Okay, hold it. B times O makes P. And C times O makes Q. Then in the manner similar to the foregoing, we can prove that D, L, and E, so it'd be D, L, and E, and G, M, N, and H. G, M, N, and H are continuously proportional to the ratio A to B. What does that mean? As D is to L, so is L is to E. Alright? As G is to M, so is N is to H. We can prove that. And further, E, O, and F. Well, here's E, here's O, and here's F. Okay, they're going to talk about continuously proportional. So, as E is to O, so as O is to F. Okay? And H, P, Q, and K. Well, let's see. As H is to P, so as Q is to K. Now the first set of letters I talked about, which was the D, L, and E, and the G, M, N, and H, remember I told you that a few minutes ago, and I said they were continuously proportional? They're continuously proportional to A to B. So in other words, as A is to B, so is D is to L, and so is L is to E, and so is G is to M, and so is N is to H. Get that? Alright. Same deal. As B is to C, so is E is to O, and O is to F, and so is H is to P, and so is Q is to K. Now as A is to B, so is B is to C. As A is to B, so is B is to C. Therefore, D, L, and E are in the same ratio with E, O, and F. So in other words, as D is to L and L is to E, so also is, hold on, E is to O and O is to F. They're in the same ratio. Furthermore, G, M, N, and H, as G is to M, so as N is to H, is in the same ratio as H is to P and Q is to K. They're all in the same ratio. And the multitude of D, L, and E is equal to the multitude of E, O, and F, and that of G, M, N, and H to that of H, P, Q, and K. Therefore, Xi quali. As D is to E, so is E is to F. So as D is to E, so is E is to F. Okay? As G is to H, okay, so is H is to K. And this is by Euclid Book 7, proposition number 14. And that, my dear friends, is the end of the proof. Alright, I will tell you more in my next video. So I want you to stay tuned.